if we placed all of our numbers into our equation, we were left with this guy. 0 is equal to 1.5 Vy times 6.5, 1/2 9.81 and 6.5 squared. Now remember that there's no hay pierde aquí. There's nothing that should have come out of nowhere. We knew how high the arrow was originally. We knew how much time it took to get there. We already know gravity, and then again we know the time. So let me just save you some time on your math. If you did all your math correctly, okay, then you end up with an equation that looks like this. 0 is equal to 1.5, 6.5 Vy minus 207.23. And if you did that math correctly, you're going to end up with a velocity in the y direction of 31.7. Now, if you want to look at the math, go ahead and take a look at my problem on the board. Go ahead and pause this video, fast forward, whatever you need to do. But that is your final velocity, 31.7, which is really cool because it means that this arrow is actually traveling with a forward velocity of 15 and an upwards velocity of 31.7. So a question for you is, how is the person holding the arrow? So take a look at these numbers here and try to pause and think about it. This guy is going 15 meters per second. This guy's going 31 meters per second, more or less. How do you think the person is holding the arrow? Is he holding it straight, slight angle, big angle? Is he holding it down? How do you think this person is holding the arrow? Well, pay attention to the fact that this guy is half of the speed of this guy. In other words, it's traveling faster going up than going sideways. So the person is actually holding this arrow at an angle where this is double the speed. So he's probably holding it around that angle right there. Okay? For funsies. Now, try this question out. Now that you know both velocities, after 3 seconds, how high does the arrow go? So after 3 seconds, how high does the arrow go? And let's see.